Okay, so can you tell me graphically what do those two equations represent? They represent lines. What did you solve for? Where they intersect. Okay, so today we are working with systems of equations. It says linear. There's going to be a couple that are non-linear, but we're working with systems of equations. What you just did, and I don't know why I still haven't changed the slide. I really should make these the lines that you just did. But we have two lines. They're intersecting at a point. Okay, so our methods to solve. Sarah, do you remember what this is called? Does anybody remember what Sarah's method was called? Elimination. Elimination. Elimination is when you multiply your equation by a number, or both equations by numbers, so that your x's or y's become opposites and you can add them together and one of your variables is eliminated. Okay? Ryan, what is your method called? Someone help out Ryan. Substitution. Okay? You have come to a point in your math career that I am not going to tell you which one of these to use when you have a two-variable system. Okay? Two variables like x and y. All right, tomorrow we're going to get into three-variable systems, but for right now, two-variable systems. I'm not going to tell you which one to use. There are going to be times when substitution is easier. There are going to be times when elimination is easier, but both are just as effective. Okay. All right. Let's talk about the number of solutions. So you guys just told me that we had two lines intersecting at a point. I want you and your pod to talk about, are there any other options for solutions and what would that look like? Okay, we have two lines intersecting at one point. Is that the only case? If not, talk about what the other cases are. Okay.
It's not a line.
If you don't know the people in your pod, introduce yourselves. We have new seats. Okay. Pod 3, what do you got for me?
Well, if you got two parallel lines and they never intersect, we might have zero solutions.
Okay, we could have, let me stop you there. Sorry, thank you. We could have two parallel lines that don't intersect. Therefore, there would be no solution. Okay. Algebraically, what's going to happen? Algebraically, our slope is the same. What about if you get to here? Okay, we actually got numbers here, right?
So you get something where like everything cancels out and you're just left with the 0 equals 0.
Not quite. Almost. Because 0 equals 0 is a true statement.
It's like
It won't be
17
true.
equals negative
It
1.
won't be true.
Right. So like if you get like 0 equals 5, or so what did you say, 17 equals. Okay, if you get down to where the x's and y's all go away and you get a number equals a different number, obviously it's not okay. That's when we have no solution. Okay? Pod 6, do you talk about anything besides parallel lines? No?
Not really.
Okay. Pod 5?
We said you could have like a parabola or something of multiple degrees and then have a line pass through and then pass through multiple times.
Okay, so if we had like a line and a quadratic, we're probably going to get two solutions. Okay, good. Pod 3, anything that hasn't been mentioned. Your 4, sorry, your sign keeps spinning around. Anything that hasn't been mentioned. Okay, I'll draw that up. Okay, over here, like I'll put to the side, if we have a parabola and a line, we could have the two solutions. Okay, there's one more case for two lines. Darby, you're very excited.
We have a line and another line, and it's the same line, then everything's a solution.
Okay, if we have two lines that are the same, then we have infinite solutions. And that is when we get the case of 0 equals 0. Okay, if in your algebra everything cancels out and you have a true statement, 0 equals 0, 5 equals 5, that is when we would have infinite solutions. We have the same line. Okay? All right, now, I know that you know how to solve these. Today, I am not worried about solving these. We're going to work on a word problem, and we're also going to look at a case when we have a parabola in a line and how that's going to look. Okay? So, first example. Now, I don't want you to write every single word down. Let's highlight some information for you to write down. Okay? So, an airplane flying into a headwind travels a 2,000-mile flying distance. Okay? So, our airplane is flying 2,000 miles. That's important. I don't really care where they're flying to. And flying there, it takes 4 hours and 24 minutes. On the return flight, obviously the same distance. So to get there, it took them 4 hours and 24 minutes. To get back, it took them 4 hours. Okay? Find the airspeed of the plane and the speed of the wind. So we want speed of the plane, speed of the wind. When we are working with word problems, what is the very first thing we have to consider?
What are variables?
What our variables are. We cannot write equations if we do not define what our variables are. So let me tell you this. If you do not define what your variables are on a word problem, your work is not correct. Okay? That is the first thing that you have to look for. So we all like X and Y. We're very comfortable with those variables. Okay? Don't feel like you have to use X and Y. You can use A, you can use any letter of the alphabet that you want to. Okay? But we're looking for two things. We are looking for the speed of the plane, and we are looking for the speed of the wind. What is going to be the measurement of each of these speeds? Miles per hour. We're traveling miles. We have time of hours, so I'm going to go ahead. Miles per hour. Okay. All right, one thing that bothers me is our time to get there. I don't like that it's 4 hours and 24 minutes. Let's just write it in terms of hours. How do we do that? Okay, 24 divided by 60, what is it?
4 cents.
Okay, so this is the same thing as 4.4 hours, and that's the number that we want to use because we don't want the minutes in there. Okay, all right, so we need two equations for our two variables. We have pieces of information about getting there and coming home. Okay, You are dealing with a problem with distance, speed, and time. Rack up that science brain. How do we relate those three? Distance equals
Rate times time.
rate times time. That's going to be very important for you to remember. You're going to use it often. All right, so let's talk about the trip there. What's the distance to get there? 2,000 miles. What's the time it takes to get there? 4.4 hours. What's the rate at which the plane is really traveling? It is not going X because it's traveling into the wind. Oh, what?
X minus one.
X minus Y. The plane is traveling X, but the wind is slowing them down by however fast the wind is blowing. So X minus Y is actually the rate. They're going slower. That wind is slowing them down. Let's talk about the trip back. What was the distance they traveled? 2,000. Okay. We'll talk about the rate here pretty soon. How long did it take them to get back? 4 hours. Okay. Now this time, okay, going there, they were into the wind. Now they're going with the wind. How fast is the plane really going? X plus Y, because the wind is helping them out. Okay. So this is our system. Okay. This is the hard part, writing the equations. Now we're very comfortable with the algebra. Okay. All right. Any suggestions on how to solve this? What? No, because technically this is 2,000 equals 4.4x minus 4.4y, and this is 2,000 equals 4x plus 4y. Okay, and which equation would you like to take the second one, x or y? Doesn't matter. What's nice about this is 2,000 is divisible by 4, right? So we can take 2,000 and subtract 4y, and then divide it by 4 to get x is 500 minus y. Okay. Then we can take that and plug it into our first equation. Don't plug it back into the same one. You're just going to undo everything you worked so hard to do. So we have 2,000 equals 4.4x minus 4.4y. What's 4.4 times 500?
22.
Okay, so if we subtract that over, we have negative 200 equals negative 8.8y. What is y? What?
22.727272.
Like that? Okay. So we have found y. This is very easy now, right? We can go back up to here. Take 500 minus y to get x. 500 minus 22.727272 is that, right? Now, would I be happy with this as your answer?
No.
I'd be happy that you did the algebra correct, but I would not be happy with how you wrote your answer. Okay? I need you to tell me that, what did X stand for? Oh, look, we labeled it. Speed of the plane. Okay? The plane is traveling 477.27 miles per hour. And the wind is blowing 22.72 miles per hour. I guess technically that would be 730, wouldn't it? For rounding. Okay? When you have written down everything that you need to, you may go to lunch. We will look at a couple more problems when we return, and if you have any questions, we'll address those after lunch. Were there any questions about our airplane example? Okay. You are going to have word problems in your homework, and you are going to attempt them. Okay. Make sure you label the variables. Look at what the question is asking you to find. Usually that will tell you what your variables need to be. Okay. All right. Let's try an example that looks like this. Can anyone tell me what x squared plus y squared equals 5 is?
Circles.
A circle with radius? Radical 5. Okay? So we have a circle and a line. We could have how many solutions? 2. We could have 2, we could have 1, we could have none. Okay, it's possible that this line doesn't even cross through. Okay, more than likely it does. But it is possible for a line to go through twice on a circle, once on a circle, or not at all. So let's see what happens. Is elimination a good strategy to use here?
No.
It is not going to be a good strategy to use. Okay, so we're going to have to use substitution. So this is one of those times where I'm not telling you what to use, but there's only one way to do it. Okay. Now we can either solve for x or solve for y. That is up to you. Anybody have a preference?
X. Please.
Let's vote. Who would like to solve for x? Who would like to solve for y? Okay, and the rest don't care? We will solve for x. So x equals 1 minus y. Plug that into the first equation. 1 minus y squared plus y squared equals 5. Now, ladies and gentlemen, what does 1 minus y squared mean?
We have to FOIL.
Okay, we're going to have to multiply 1 minus y times 1 minus y. It is not 1 minus y squared. Okay, what kind of problem are we working with here? Quadratic. Okay, we have 2y squared minus 2y plus 1 equals 5. Anytime we have a quadratic, we needed to set it equal to 0. So we have 2y squared minus 2y minus 4 equals 0. What can we do with that? Okay. Okay. Now we can see if we can factor. What multiplies to negative 2 but adds to negative 1? Okay, so our y values are 2 and 1. Okay, this makes sense. We have a circle and a line, so it's possible for us to have two different points here. Now what do we do with these? Plug them back in. And we've already solved for x here, so those are easy to plug in. If y equals 2, then we have x equals 1 minus 2. Okay. If y equals negative 1, then x equals 2. So we have two solutions. Okay? You need to actually write me the coordinate negative 1, 2. And you need to write me the coordinate 2, negative 1. Okay? The coordinate is the point of intersection. The coordinate is your answer. I am not okay with x equals 2, y equals negative 1. You need to write it as a coordinate. Questions on the algebra that we just did? Okay. Excuse me. One more example. I want to show you what happens algebraically. What? When something special happens, yes. I'm going to show you what happens when everything on the left side cancels out. If we use elimination, what would be a good number to multiply our first equation by? 2. Okay. If we multiply our first equation by 2, we have 2x minus 4y equals 6. Okay. Some of you already see what is going to happen. Please still write down your work. So some of your work is kind of proof of what's going on here. What happens? The x's cancel and the y's cancel, but we get 0 equals 7. Is that a true statement? It is not. So this is what it looks like algebraically when we have no solution. Which means what about those two lines? They're parallel. They will never cross. If these two are the same line, then this would have been 0 equals 0 for our elimination. Okay? If you were using substitution, you probably would not have gotten these exact same numbers, but you would have gotten an untrue statement telling you that it was no solution. Okay? All right. So this is kind of nice. You have time to begin your homework. I have a gold sheet for you, so don't feel like you have to copy this down. Now, I will tell you that Section 1 deals solely with substitution. Section 2 deals solely with elimination. I'm okay with you choosing whichever method to solve linear systems. Okay, if you have two lines, I really don't care if you use elimination or substitution. Okay, in that case, you can ignore the instructions.